Hello YouTube. Since my family members located around the country had some questions about my FPV hobby, I decided to do a video about it. It came out okay, so I'm posting it to my YouTube channel. This is very basic, so if you're already into FPV, it will not be for you. I'm also going to add some Q&As at the end to fill in the questions I most often get about FPV. Here's the video. Hello everyone. I've had a number of questions about my FPV hobby, so I thought I'd make a video about what FPV is, how it works, and what quadcopters I fly. Now, this is not a recommendation or a review of any of these items. It's just what I use and what I enjoy. So first, you can't really understand flying first-person view, FPV, without a little understanding about flying quadcopters, so I thought I'd begin there. All quadcopters, regardless of size, share basically the same components. A frame, 4 motors, that's what makes it a quadcopter, 4 ESCs or electronic speed controllers, one to control each motor, a flight controller, a receiver, and a transmitter. Motors are sized for the size of the quadcopter you're flying. These tiny motors are for small indoor models. These medium ones for medium-sized quads, and of course big ones are for large quads. ESCs are also sized based on the motors you're using. Also, ESCs can be made as a single component, like these you attach to the arms of the quadcopter, or 4 ESCs can be combined on a single board to reduce weight. Flight controllers are the brains of the quadcopter. When you increase the throttle on your transmitter and pitch the craft forward to fly forward, the flight controller brain uses a gyro to determine the speed needed for each motor to spin to fly in the desired direction. Of course, there are a lot of electronics and software going on to make all this work, but all flight controllers are basically translating the pilot's stick movements to the motors through the electronic speed controllers. The receiver connects to the flight controller and receives the inputs from the transmitter. The transmitter, and there are a whole variety of shapes and sizes of these, is translating your stick movements into a signal that it sends to the receiver. On this transmitter, throttle and yaw are on the left, pitch and roll are on the right. So that's basically it. Plug a battery in the quadcopter, arm it, which is just a safety feature so it doesn't fly away when you aren't ready. Increase the throttle, push the stick in the direction you want to go, and you're off. Of course, it takes a bit of practice to fly a quadcopter smoothly and not crash it. So whether a person flies line of sight, sometimes referred to as LOS, or FPV, the quadcopter construction is basically the same. The difference with FPV is the addition of 3 items: a camera, a video transmitter, and goggles. For purposes of this video, I'm going to be showing the digital video system developed by DJI, since it's the system I use and it's the one that's in all my quads. There are other systems available in digital and analog, but going over all the differences is way out of the scope of this video. The need for a camera, video transmitter, and goggles is shared by all the systems. So what the heck is FPV anyway? Regardless of the technology you use, it's simply a way to have your view be from the quadcopter as if you're flying inside of it. It's as if you're in the cockpit of the quad and you are seeing the flight from the quad. It's very cool, but a bit disorienting at first. After a short time, you do get used to it. So how does it work? Well, it's pretty simple. The camera is secured to the front of the quadcopter and connected by a wire to the transmitter. The transmitter is connected to the flight controller, which provides power and also displays information, like battery voltage, on an on-screen display in your goggles. The transmitter broadcasts the image that it's getting from the camera on a specific channel that's picked up by the goggles. That image from the cameras is displayed on the screens in your goggles. I have special diopters in mine so I can wear them without my glasses. The goggles also record the video onto an SD card. So instead of flying line of sight, you fly first-person view. The stick commands are the same, but once you get used to it, I think it is actually easier than line of sight. With line of sight, when the quadcopter is facing you, the sticks are reversed. With FPV, they're always the same. Before I move on to the quadcopters I fly, I should mention a quick word about batteries. Everything I fly uses lithium polymer batteries, LiPos. They are designed to deliver a lot of power at once. Like ESCs, they are also sized to the motors you are using. Smaller LiPos are used in smaller quads, big ones in big quads. Of course, the larger the battery, the longer the flight time, but there is a trade-off with weight. Generally, you size a battery to give you the best of both. Average flight time for what I fly is about 4 to 7 minutes, depending on the size and weight of the quad, but it can vary a lot. And my quadcopters vary in size a great deal. Generally, quadcopter sizes are talked about based on the prop size. For example, a 5-inch quadcopter has 5-inch propellers, 2.5 inches per side. The distance from motor to motor can vary a bit depending on the design of the frame, but on a 5-inch it must be large enough to accommodate 5-inch props. One of the limitations of flying with the DJI digital FPV system is the size of the camera and transmitter. The smallest quadcopter I have that uses the DJI system is this 1.5-inch model. This one has the camera and transmitter removed since I don't fly it at this time of year. Though it can fly outside on a calm day, it's really designed for indoor flying, which is nice to have on a rainy or snowy day. Next up for me is this 2.5-inch model. Also best on a reasonably calm day, though it's small, it can fly pretty fast and fit in narrow areas. This one also has 2.5-inch props, but with its prop protectors and slightly larger motors, it looks much larger. The protectors make it less intimidating when flying near people, and you don't have to worry as much if you clip a branch. This can also take a slightly larger battery, which enables more flight time. Though the size of the frame on this next model is about the same as the 2.5-inch with the protectors, I can fit 3-inch props on this one. You can actually feel the additional power when you go from 2.5 to 3-inch. It's not a big deal, but it's just a slightly different experience. This next quad is a bit unusual. It also uses 3-inch props, but larger motors still to accommodate a different type and heavier DJI video transmitter. This one has an onboard video recorder. The video you are looking at now is recorded in 1080p high definition by the video transmitter. In addition, this unit has a microphone. The video recorder in the goggles records at 720p and has no microphone. This model is a bit larger and heavier, so I use bigger motors and bigger props, not in size, but with greater pitch. The pitch is the angle of the propeller blades. This quad is great for getting the best video and flies really well too. One of the newest quadcopters in my fleet is this 3.5-inch model. This is a size that has just been introduced and I'm still getting used to it. You can feel the larger prop size with more speed and control. Next up is a different class of quadcopter, the long-range 4-inch. These are built as light as possible and designed to fly high and far. I have had this one a few miles away and could probably go much further, but it makes me kind of nervous. It uses a special, lighter, lower voltage battery. Since this quad is so light, it requires much less power to fly and it can easily fly for 12 minutes. And that's about as long as I want to fly on one setting. My final two quads are really designed for flying in a space much larger than behind the house. This 5-inch quad is very fast and very stable. Even in some wind, it's very steady. It is capable of doing flips and rolls, but near the house I don't chance those. I don't want to crash into someone's car. Finally is my largest FPV quad, my 7-incher. This one is equipped with GPS and can stay in position at a fixed altitude with the flick of a switch. It is also capable of automatically returning to the home position if it loses signal or if I activate the return to home setting. It also has one of the full-size DJI recording devices I mentioned earlier. Though I recorded this footage at the house, I usually fly this out at the large field in front of our development. So that's the fleet. I am by no means the greatest pilot, but I really enjoy tooling around and building different models and seeing how they compare in flight. I tend to use a model for a while, then move the motors and electronics to another frame to see how that works. For example, the 3.5-inch model I showed you used motors and electronics from an older 3-inch model. I just really enjoy the building part and designing and printing 3D parts to finish the build. For example, the camera mount, the landing gear, and the antenna mount were all designed and printed by me on my 3D printer behind me here. Well, this video is certainly long enough. I hope you enjoyed it, and thanks for watching. Well, I used to build and fly RC airplanes. I still do. But I got interested in FPV a couple of years ago. I tried it out, I liked it, and I thought, it would be fun. If you're thinking about starting an FPV and have never flown any radio control, I suggest you start with a simulator. There are many of these, and they're not that expensive, so it'll give you a good idea of whether FPV is right for you. Well, you can spend hundreds of dollars or you can spend thousands of dollars. You really do have to research all the options before you start buying. There are a lot of them. I think DJI has the best picture, the best penetration and range, and is the most immersive of all the technologies. My eyes are not as good as they used to be, and the sharpness and high definition of DJI really helps. But it's expensive. It's the most expensive of the FPV technologies. Both the goggles and the video transmitter and the cameras are expensive. And it's a proprietary DJI technology, so that's something else you should consider. It's not open source. DJI is really the only manufacturer and developer of this system. Well, no, there are many ready-to-fly options. Off-the-shelf quadcopters you can pick up, put a battery in, and obviously if you have the other equipment, you can go fly. However, most people crash, and you have to know how to fix the quad. And if you know how to fix the quad, it will make the hobby more enjoyable and less costly. I really enjoy building as much as I do flying. If your interest is FPV, then you should check out Joshua Bardwell, the FPV Know-It-All. He has both a website and a YouTube channel, and they're excellent. If you want broader information about radio control, including FPV, Lee Schofield's channel, Painless 360, has terrific information about all aspects of the RC hobby. There are many, many more YouTubers and websites that specialize in different aspects of the hobby, so you can just search for FPV or search for radio control. So that's going to do it for today. As Lee Schofield says, happy flying.